Alright, in these next two videos we'll be doing section 2.4. The first part is going to be focusing on what we call a library of functions. These are 8 functions that you really need to be familiar with because you want to be able to graph them without plotting any points or without using a calculator, and also because that we can see that a lot of the algebraic functions we'll see actually come from these 8 functions. The other topic from this course, or this section, will be piecewise defined functions. But in this video, we'll just focusing on this collection, or this library of functions. And it could be a lot of the graphs we've seen before. First is the identity function. That's just the function that sends x to x. Okay, and the graph, of course, it's just going to be the graph of y equals x. And I think we've seen that before. Obviously, the domain is all reals. And the range will be all reals. And we can also see that this function is increasing everywhere. Right. Okay. The second function is really a series of functions. These are constant functions. It just means that you have only one output. So in this particular case, f is a function that sends all the real numbers to the same number b, where b is a real constant. And the graph of that is going to be a horizontal line. Okay, in this case, it will be at b, whatever that is. Okay, so the domain would be all reals. And the reason, again, for that is, even though you don't see any x here, the important thing is that it doesn't matter if the output has an x in it or not. The important thing is that there's always an output for every input. Okay, so and if x can be any real number, the outputs always exists. So the domain is all reals. The range, well, it just consists of one number, namely b, because that's the only output. Okay. And obviously this is going to be constant everywhere. So we can say constant on minus, well, I guess just say constant everywhere to be consistent. Instead of everywhere, you could also say minus infinity to infinity. That would also be acceptable. The square function, we've looked at that. That is a parabola, where the graph is a parabola. Okay, this is the graph of y equals x squared. Okay, I think you've seen that many times. You can plot a few points. We can see it's decreasing and then it's increasing. In particular, it's decreasing. From minus infinity to 0, and it's increasing on 0 to infinity. Okay, and I should say the domain is all reals, and the range, in this case we can see a range corresponds to the y coordinates, and those are just the non-negative real numbers. So it's 0 to infinity. Okay. The Q function, well, the graph looks like this. When x is negative, x cubed is negative. When x is positive, x cubed is positive. And it goes through 0, or it goes through the origin. And so the graph looks like this. Okay, we've seen that it's an odd function. Okay. And we can see it's increasing everywhere. And I'll let you fill in this, but the domain and the range will be all real numbers. I think you can see that. Square root function. This only, x has to be a non-negative number. X can't be negative. So the domain, as we've seen, x has to be greater than or equal to 0. So that means the domain goes from 0 to infinity. And in fact, the graph looks like this. It starts at the origin and increases. It doesn't increase too fast. It's not as fast as the other two graphs that we've seen. So, but it's increasing on 0 to infinity. And I should say that the range, where the y values, those are also going to be the non-negative numbers. The cube root function, it's kind of similar to the cube function, but it's in a way it's different. And the important thing is that it goes both those functions go through the origin, but when the cube root function graph goes through the origin, the graph is actually like a vertical line, almost like a vertical line at the origin. And it shoots off, but it doesn't shoot off as fast as it does for x cubed. Okay. So again, we can say that it's the domain is everything, because we can take the cube root of any number, unlike the square root. For example, the cube root of -1 is -1. So we have that. So the domain and the range are all reals. Okay, and then and we can see it's increasing everywhere. Okay, we're increasing on minus infinity to infinity, if you like. Okay. The reciprocal function, we know that this is defined everywhere except x is 0. And if x is a really big number, like 1 million, we know that 1 over 1 million is a very small number. Okay. Conversely, if x is, let's say, 1/2, 1 over x is 2. If x is 1/10, 1 over x is 10, and so on. So we have this phenomenon. When x is very large, 1 over x is very small, and vice versa. And this, in fact, is an odd function. And the graph looks like that. The domain would be all x not equal to 0. And the range would be the same way. Okay, I guess all y not equal to 0. Okay. In interval notation, this would be negative infinity to 0, union 0 to infinity. And the same for the range. Okay. We can see it's decreasing, but we have to be a little careful. We can't say it's decreasing everywhere. We say it's decreasing from here to here. So what's here to here? That's from minus infinity to 0. And then it's also decreasing from 0 to infinity. Okay. This is kind of important, because it would be incorrect to say it's decreasing from negative infinity to 0, because the values of 1 over x are actually higher here than they are here, but we wouldn't say that it's increasing. And then the absolute value function, you've maybe seen this before. The graph looks like a V shape. Okay. Okay, so we can see the domain is going to be everything. And the domain is all reals. The range would be the numbers from 0 to infinity. And we can see it's decreasing on negative infinity to 0, and it's increasing on 0 to infinity. Okay, and this graph is actually two lines intersecting at the origin of the right angle, and we'll pick up on that on the next video. So these are the 8 functions you should be able to graph automatically, at least without using a calculator and without plotting any points. And you'll see they're pretty fundamental.